Oh. All right, so today we are going to finish part 2 of our 4.2 notes. We're going to talk about the bounds, theorem for bounds on zeros. So negative m less than or equal to any zero of f less than or equal to m. The bounds on zero says if I have a function whose leading coefficient is 1, we're going to choose the largest entry from 1 to whatever the sum of my coefficients is, or 1 plus the largest entry of each one of my coefficients listed. The absolute value of. So let's see what that looks like. All right, we're going to find a bound on the real zeros of each polynomial function. So we're going to look at our first one, f of x equals x to the 5th plus 3x squared minus 9x squared plus 5. The leading coefficient is 1, so we can use our bounds on zeros theorem. So we want to find the maximum value. It's either 1 or the sum of the other constants. And if you notice, I am missing a x term, so that becomes a 0. And x term and a fourth, x to the 4th term, so those two are zeros. So if you look, what is the max value of 1 and 17? And the answer is 17. So that is one of our bounds on our zero. The other bound on our zero is going to be 1 plus whichever value, absolute value of our coefficients, gives us the biggest number. So 1 plus, we look at absolute value 5, 0, negative 9, 3, and 0. Our max is going to be the absolute value of 9. And 1 plus 9 is 10. So the smaller of the two numbers, 10, is the bound. Every real zero of f lies between negative 10 and 10. So please note you pick the smaller of the two numbers, and the negative version and the positive version will tell you where your zero lies. Pretty cool. Let's try it with b. So for b, my leading coefficient is not 1, so I have to factor out the 4 so I can get a leading coefficient of 1. So all I did is I divided each of my terms by 4 to get x to the 5th, negative 1/2 x cubed plus 1/2 x squared plus 1/4. All right, so I want to find the maximum number. My choices are either 1 or the sum of the coefficients. So 1 or 1/4 plus 0 for that x to the 4th term, plus 1/2 plus negative 1/2 plus 0 plus, they listed these backwards. I'm not sure what they were doing. Oh, it's because they put A0 first. That's why. So there's A0, A1, A2, A3, and A4. And when we add all those together, we get 5/4. So what's the max between 1 and 5/4? That's 5/4. Okay, we're going to do the same thing, but we're going to go 1 plus the absolute value of whoever's biggest, 1/4, 0, 1/2, negative 1/2, or 0. So in this case, our biggest one, absolute value of 1/2 is 1/2. I'm going to add 1 to that. So it's 3 halves. So we have to decide which one is smaller, 5/4 or 3 halves. And we get the smaller of the two numbers is 5/4. So every real zero of G lies between negative 5/4 and positive 5/4. All right, we are going to look at using the intermediate value theorem. That's our last learning objective. If f is a polynomial function, a is less than b, and if f of a and f of b are of opposite sign, then there's one real zero between a and b. So if you have f of a anywhere here, and you get a negative, and then f of b is positive, then you know you have a zero between the two. So we're going to use that to locate a real zero. We want to show that f of x equals x to the fifth minus x cubed minus 1 has a zero between 1 and 2. So let's go ahead and plug in f of 1. 1 to the fifth is 1, minus 1 to the third, 1 is 1, 1 minus 1 is 0, and minus 1 is negative 1. If I plug in 2, 2 to the fifth is 32, minus 2 to the third is 8, 32 minus 8, minus 1 is 23. So f of 1 is negative, f of 2 is positive. I must have a 0 between 1 and 2. Okay, so if I'm going to approximate the zeros of a polynomial function, I'm going to find two consecutive integers, a and a plus 1, such that f has a 0 between them. I'm going to divide the interval into 10 equal sub-intervals. So if it's between 1 and 2, I'm going to go 1.1, 1.2, 1.3, 1.4, 1.5. Evaluate f at each endpoint of the sub-intervals until the intermediate value theorem applies. This interval then contains a 0. We're going to repeat the process starting at step 2 until the desired accuracy is achieved. So let's see how that looks. So we want the 0 correct 2 decimal places. So I'm going to plug in f of 0, 1.0, 1.1, 1.2, and 1.3. We're going to keep going with the points. We already plugged this in and found it. We're going to keep going until we can see this was negative, now this is positive. So we're going to go start over at 1.2, then we're going to go 1.21, 1.22, 1.23, 1.24, and follow that process until we get a sign change. And then we can say that our answer is between 1.23 and 1.24. So we can say it's 1.24, I think would be the accurate statement. And that's all for part 2.